Alright, so here is video 2 for the roots. We're going to be talking about multiplying two radicals and how to simplify a radical based on the multiplication principle. So if we look at multiplying radicals and we do sort of a quick example, we look at radical 4 times radical 9, and let's look at radical 4 times 9. On the left-hand side, the square root of 4 is 2, and the square root of 9 is 3. So if we take radical 4 and multiply it by radical 9, it's the same thing as multiplying 2 by 3, and 2 times 3 is 6. 4 times 9, on the other hand, is 36, and so this radical is 6. And we see that we get the same thing either way. And so this should lead us to the belief that the square root of a times the square root of b is just the square root of a times b. Now, there's going to be a justification here, and I'm going to fill it in a second, but let's look at radical negative 4 times radical negative 9 and radical negative 4 times negative 9. On the right-hand side, we have two negatives, which when you multiply give you a positive. So we get radical 36, which again evaluates to 6. But over here, this is not okay. And this is not okay. And not surprisingly, the multiplication of two things which are not okay is not okay. And so you see where we got 6 on one side by doing the multiplication under the radical first and then taking the square root. But on the left, we weren't even able to calculate the two radicals, let alone multiply their results. And so the reason is that this only works, we're only able to combine underneath if what's underneath is positive. If A and B are both positive. And so if you look at something like radical 9 times radical x squared, right, and radical 9x squared, it turns out that both of these sides are equal, right, as long as 9 is positive, which it is, and as long as x squared is positive, which it is. So sometimes instead of computing the right side, the left side here is actually easier. And so most of the time we're going to use this rule to do the following. Switch it up. Take the product underneath and write it as two radicals. The square root of 9 is 3, the square root of x squared is x. And so radical 9x squared is just 3x. Sometimes, however, we're going to use it to make our lives easier. Look at radical 2 times radical 8. If we combine these, 2 times 8, and 2 times 8 is 16, and the square root of 16 is 4. And so that makes life easier for us. If I take radical 3x times radical 12x, well then what I get is radical 3x times 12x, and 3 times 12 is 36. X times x is x squared. And look, I can break it back up by using the same rules. And so that's 6 times x. So we took these and combined them, and then after combining them, broke it back up so that we could take the square roots easily. So let's look at simplifying. If we want to simplify a radical, say we take the square root of 50, well, let's talk about what we're going to do. We're going to try to write 50 as the product of two numbers, one of which is a square, and the other of which is non-square. And so we can write 50 as 25 times 2. Like that. And then our rule from before said, as long as both are positive, the right side and the left side here are actually totally equal. And so we can transform radical 25 times 2 to radical 25 times radical 2, and this is just 5. And radical 2 doesn't break down any further. And so this is a simplified version of radical 50. And so the strategy is whenever you have radical anything, factor anything into the largest square times everything else. So sometimes you have a number that might be a little too big to find the square root inside, and so maybe what you need to do is start by factoring it. So let's start with 300 at the top, and we get 3 times 100. Well, that one happened quickly, didn't it? Because 100 is a perfect square, and so it's radical 3 times radical 100, and the square root of 100 is 10, so we get 10 radical 3. And so let's try maybe the square root of 486. Well, that is definitely not as obvious. And so if we start with 486 here at the top, and we start trying to pull out numbers, we get 2, and 2 goes into 486 243 times. Now, 2 plus 4 plus 3 is 9, and so 9 goes into there. 9 goes into 24 twice, with a remainder of 6, and we get 63, so we get 27, and 27 is 9 times 3. Now, once you've made your factor tree, you can stop every time you have a perfect square. 9's a perfect square, so I didn't factor it. This 9's also a perfect square, so I didn't factor it. And so this is the square root of 2 times 9 times 9 times 3, which is the same thing as radical 2, radical 9, radical 9, radical 3. Now, these are each 3. And so I get 3 times 3 times radical 2, radical 3. Now, let me go ahead, make a little space. Three times 3 is 9, and remember we can recombine these into one radical. 2 times 3 is 6. And so our final answer there is 9 radical 6. Lastly, let's see what happens when we multiply a couple of things that have the square roots. So say we take the square root of 18x cubed and multiply it by the square root of 30x to the 5th. Well, step 1 is to take these two and combine them into one. So we have 18 times x cubed times 30 times x to the 5th. Step 2 is to combine like things. So we're going to multiply the x's and we're going to multiply the numbers. And so we get 18 times 30 times x to the 8th. And remember, it's 8 because 3 plus 5 is 8. Now, let's work on 18 and 30. 18 is 9 times 2, and 30 is 2 times 15. So 18 times 30 is actually 9 times 2 times 2 times 15. And 15 is 3 times 5. And so we get 9 times 4 times 3 times 5. These are both perfect squares. This is nothing. It's two prime numbers, neither of which are going to be perfect squares, and so that's not going to be useful, but 18 and 30 can be written as, so we get down here, equals the square root of 9 times the square root of 4 times the square root of 3 times 5, which is 15, times the square root of x to the 8th. And so we get 3 times 2 times x to the 4th times radical 15. And so our final answer, right, 3 times 2 times x to the 4th times radical 15 is just 6 x to the 4th radical 15. So that's kind of it. The big idea in this chapter is the fact that you can take two radicals and multiply them underneath as long as they're both positive beforehand in the radicand, and you could also take a multiplication and sort of factor the radicals into two radicals. And so we did some examples where we factored the radicals into two or more radicals in order to be able to do the computations. So go ahead, do the homework, and I will see you in class tomorrow.